Hi guys. So we've got one more little thing to talk about before your final check on solving systems of equations. And unfortunately, it's the thing that everybody kind of really hates, word problems. Luckily though, this is the last, not only the last bit of new material before your check, but the last bit of new material that you're going to learn for this entire school year. That's kind of crazy. So it covers a bunch of stuff in chapter 5. It's kind of a combination of solving by substitution and solving by elimination. And I did end up putting that poll up on Classroom just to kind of see where you guys were at in terms of what you preferred. And I think the majority of people said either they preferred elimination or that it depends on the problem, whether to use substitution or elimination. So I think there's going to be some situations throughout these problems in this video that elimination might be easier or substitution might be easier. We'll see. As I said last time, regardless of which method you prefer or which method you choose to use to solve a system, as long as you know what you're doing and you're doing everything carefully, showing all your work, all that fun stuff, you should get the exact same answer at the end. Yeah. So the thing with word problems and systems is, like, we've seen systems deals with two equations, right? So when we set up a system, we're obviously going to have to set up not one, but two equations in two variables. So we have to be careful about what our equations are talking about and what our variables represent. We have to be extra careful this time because there's two of them now. So the two equations that we're going to be setting up are going to be representing two different things. Usually if we're comparing two quantities, we have two different equations to represent the two different quantities. Or a lot of the times you're dealing with comparing things involving two different people, so you would have two different equations to set up in regards to, like, one representing one person. Kind of get what I'm saying? Let's just kind of jump right in. All right, I think this one might be slightly more complicated, but sometimes it doesn't hurt to start out with something slightly more difficult. So, an exam worth 145 points has 50 questions. Some questions are worth 2 points and some are worth 5 points. How many 2-point questions are there? How many 5-point questions are there? So I think everybody's pretty used to now, the first thing that you do when you have a word problem is highlight or underline the key information. So a lot of the key information does boil down to the numbers. The exam is worth 145 points and has 50 questions. There are 2-point questions and there are 5-point questions. And you're looking for how many of each there are. And we are led to believe that those are the only two types of questions. This 50 question exam is it only consists of 2-point questions and 5-point questions, and that's it. There's no 1-point questions, no 3-point questions, nothing that would make our lives even more complicated. So the two different things that we're comparing are the points and the questions. So since I said that the 50 question exam just has those two types of questions, the sum of those amounts of questions would be equal to 50. So if you were going to write an equation to represent that, let's say X represents the amount of 2-point questions and Y represents the amount of 5-point questions. So the total of X plus Y, 2-point questions and 5-point questions, equals 50 questions in total. That's the first equation. That deals with the number of questions. And the other equation is going to represent the point value. A lot of times I like to use X and Y. In reality, you could use whatever variable you want. If you wanted, like, T for 2-point questions and F for 5-point questions, that's up to you. I know we've been used to X and Y, so I might use that more often, but we'll see how it goes, So we're going to deal with X and Y. So the total point value, we know, has to add up to 145. But if you have, so let's think about this in terms of the rest of the equation. If you have one 2-point question, let's say, you know that that single question is going to be worth 2 points. If you have 2 questions that are worth 2 points each, the total point values for those 2 equations is going to total up to 4 points. And it would follow in that pattern, 6, 8, etc., etc. So in general, you could say 2x for the value of the total of 2-point questions. All right? And it would be the same thing for the y. You would add up, since that's the only other type of question we have, 5 points times however many 5-point questions there are. And that is the value of the total of 5-point questions. So there's your system. Okay? You're more than welcome to bug me as much as you want in case setting up the system is still kind of confusing. We're going to do a whole bunch of examples throughout this video. This might be somewhat of a long video. But as with all the different types of word problems that we've seen, I think setting up the system is the hardest part. So once we have that taken care of, we can go in and solve it. This could be done or could be solved either with substitution or elimination. I think a lot of the ones that we're going to see later are going to be way easier to solve via elimination. So let's go for substitution for this one. So we have to pick one of these to solve for either x or y. I'm going to definitely pick this one to solve, and it really doesn't matter. So let's go with x to solve. To solve this for x, you would subtract y from both sides. So it would be, I'm going to do this over here. X equals negative y plus 50. And then we're going to plug this expression in for x in the second equation. So this is 2 times negative y plus 50. Another thing with word problems is that because these are real life situations, you should expect to get relatively large numbers no matter what. So this is negative 2y plus 100. So 3y plus 100. 145 minus 100. 45. So y is, you can't even see that. Y is 15. And we're going to talk about what that means after the problem ends. Because now we need to find x. We can plug this 15 into either one of these 2 original equations. The first one is way easier. X plus 15 equals 50. So you subtract 15 from both sides, and x is 35. Now, since this is a word problem, we do need units at the end. All right? And you're, kind of like a little sentence or a little phrase to explain what these numbers actually mean. And you have to think back, well, what did x and y represent in the original problem? Well, x and y here was just the sum of the 2 types of questions. But since the 2x down here corresponded with the 2-point questions, x represents how many 2-point questions there were. And then y would represent how many 5-point questions there were. So the little phrase that you would write at the end of all this would be something like 35 2-point questions, 15 5-point questions. Something like that is completely fine in terms of writing it out, units. Again, because it's a word problem, I'm going to want units rather than writing it as an ordered pair. If you were just solving a system with no context, then definitely write your final answer as an ordered pair. Otherwise, something like this, with units. All right? So, let's see what else is here. Eloise's family spent $134 on 2 adult tickets and 3 youth tickets at an amusement park. Lily's family spent $146 on 3 adult tickets and 2 youth tickets at the same amusement park again, we're led to believe. What are the prices of single adult and youth tickets? So this is one of those situations, like I was saying earlier, to represent the 2 different people. All right, there are two different people, Eloise and Lily, who are doing very similar things. They're both buying tickets to an amusement park. So we're going to write one equation to represent how much money Eloise and her family spent, and the other equation to represent how much money Lily and her family spent. So Eloise bought 2 adult tickets and 3 youth tickets. So I'm going to switch it up a little bit, and I'm going to say 2A, A for adult tickets, plus 3Y, Y for youth tickets. And she spent a total of $134. Lily, bought 3 adult tickets, so 3A, and 2 youth tickets, so 2Y, and she spent $146. And that's your system, all right? And then again, we can solve this however way we want. This, I think, is way easier to solve via elimination. It really doesn't matter which variable you eliminate. The numbers are exactly the same here, so we'll just randomly pick A to eliminate. The least common multiple of 2 and 3 is 6, and they're both positive, so one of them has to be negative. It really doesn't matter which one. Let's make the second one negative. So we want 3 times what is negative 6, negative 2. And then 2 times what is positive 6, positive 3. So we've got 6A plus 9Y equals whatever 134 times 3 is, 402. And then negative 6A minus 4Y is equal to, 146 times negative 2 is negative 292. So A is eliminated. 5Y equals 402 minus 292. This is 110 divided by 5. Y is 22. We'll plug that into the original, either one. Let's go with the first one just because the 134 is slightly smaller. So this is 66. Oh. 68. And then I think this is 34. Okay. So Y is 22, A is 34. And then we got to go back to think, what did those variables and these numbers actually mean? The question was asking us for what are the prices of single adult and youth tickets. So since A represented the adult ticket, we have $34 per adult ticket and $22 per youth ticket. There you go. Okay. This one is kind of similar because I'm just looking at the time here. This is really, really similar to the last one we did, where we would set up one equation to represent what Charlie does, one equation to represent what Joan does. So I'm actually going to skip this just for the time being. Maybe we can come back to it. I am definitely going to do it off camera regardless, so you have the answer to it, even if we don't get around to it. This one I do want to talk about because it is a little bit different, because we're talking about operations now for numbers. And this, unfortunately, is one of those situations where you kind of need to know every single thing that's going on in the problem. So if we asked to highlight key information, it would really kind of be everything, So what's going on here? The sum of two numbers is -1. Well, the sum is addition. The sum is the answer to an addition problem. So if we have any two numbers, again, let's call them X and Y, they add up to -1. When twice the first number and 4 times the second number are added, the sum is -10. So we're just going to go in order. X is the first number, so twice the first number and then 4 times the second number, so 4 times y are added, so plus 4y. The sum is -10. So that totals up to -10. What are those two numbers? So I'm actually going to go with elimination for this one again, just because the majority of people said I prefer elimination. And this one actually isn't so bad to solve by elimination. Because, like, let's say if we eliminate x again, the least common multiple of 1 and 2 is 2. So we don't even have to do anything with this second equation. We just have to multiply this first equation by something and then make it negative. So we want -2 as the coefficient on the x. So what is 1 times what is going to get us -2? -2. Okay? So this is -2x minus 2y is +2. The x is eliminated. 2y is -8. Y is -4. And then if we plug that back in, we'll plug that back into the first one. X minus 4 is -1. So x is 3. And the nice thing about this problem is that even though it is technically a word problem, it's really math-based, you know? It's not a real-life situation. There aren't any units. So what are the two numbers? You could just block those off separately. The two numbers are 3 and -4. You could write that in a little sentence if you want. I'd be totally fine with this. You don't even need to write an ordered pair. If this was a question on your homework or on the check or something like that, I would be totally fine with you leaving the answer like this. Let's see. I don't know. My cable got $60 set up. I actually think I'm gonna hold off. You know what? I think I'm gonna do this one off camera. Just because we're getting close, sort of, to the 20-minute mark, and I know word problems kind of stink for a lot of people. So I want to give you guys an opportunity to process, maybe rewatch this if you need to. I'll try to link some Khan Academy things if I can. And definitely reach out if you have any questions. There's usually plenty of space in the algebra, in the, what's it called? The video conference signups, the video conference sign-up sheet if anybody wants to / needs to. I definitely think it'd be a good idea for you guys to take advantage of that. And I think that's everything I have for today. The next video that you guys are going to get from me is going to be review. If you didn't see my post on Classroom already, if you guys weren't already aware, you are going to have your last check of the year on Friday on systems of equations. There are going to be some word problems in there. Probably not that many considering the check's usually been pretty short. And I think, is that everything I want to say? Yeah, I think that's everything. I feel like I'm just rambling now. Next video is review for the check, and that's going to be the last one for the year. Yeah, that's kind of crazy. Okay, I'm going to stop rambling now. I'll talk to you guys soon.